Hello, today we're going to look at lesson 1.6 and talk about design of experiments. So let's go ahead and turn in your course pack to page 47 and let's roll. So the design of experiments, we need to have some definition discussions here. Let's go back to the definition between observational study and a design experiment. So an observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. That is, in an observational study, the researcher observes the behavior of individuals without trying to influence the outcome of the study. Surveys definitely fall under this category. A design experiment is a controlled study to determine the effect varying one or more explanatory variables or factors has on a response variable. Any combination of the values of the factors is called a treatment. An experimental unit or a subject is a person, object, or some other well-defined item upon which a treatment is applied. So let's look at example 1. We have A and B here. It says, explain whether the following is an observational study or a design experiment. So I'd like you to take a minute and read through those, pause the video, and we will discuss together. So letter A, the thing I was looking for here was that they do have a treatment. They want to find an effect on a new treatment for high blood pressure, okay? And they randomly place part of them into a group to receive the drug, and then they randomly place the other group into the other. So it's definitely a designed experiment. These 1,000 people have volunteered to be part of the group, and then they knew when they volunteered that they were going to randomly either get the drug or not get the drug. And so we're not just observing them, and they chose which group to be in. They were randomly placed. And the treatment is either the drug or no drug. So letter B. They're studying air pollution on lung capacity. They gathered 500 people that already lived in high polluted cities, measured lung capacity. Then they gathered 500 people who did not live in high pollution cities and measured their lung capacity. So this is an observational study. And mainly because you can't make people live in high polluted cities. So that's what I always think about is if it's an observational study, it's something that you can't force them to do. Up here, they volunteered to be part of the group, and then they randomly chose, and some just got the medicine and some didn't, but they knew that that was a possibility. A warning down below that we want to make sure we take note of is a control group does not automatically mean that a study is an experiment. For example, a researcher compares the lung cancer rates and records of 150 non-smokers and 150 smokers. So the non-smokers would be the control group, but they didn't randomly assign them to either smoke or not smoke because ethically you couldn't do that. So page 48 has a few more definitions. One is for placebo. So a placebo is a neutral treatment that has no effect on the response variables, kind of like a sugar pill. A placebo effect is when subjects respond differently after they receive treatment, even if the treatment is a placebo. So sometimes they will do that with medical. They might say, randomly this group will get the migraine medicine, randomly this group will get a placebo, and you don't know which one you're getting. And some of the people that take the placebo might say that their headaches or their migraines are completely gone, but in reality, they were never getting the treatment. They were just getting the placebo. So they just, positive thinking in their mind thought, oh, I must be getting the drug. I'm feeling so much better. A control group is a group that receives a baseline treatment that can be used to compare to other treatments. So control groups can be established in a wide variety of ways, such as no treatment, neutral treatment, placebo, standard treatment, etc. Control group means the group that receives the baseline treatment, not that the group is controlled by the researcher. Blinding refers to non-disclosure of the treatment an experimental unit is receiving. Single blind experiment is when the experimental unit or the subject does not know which treatment they are receiving. Double blind is when neither the experimental unit nor the researcher in contact with them knows which treatment the experimental unit is receiving. So let's go ahead. I'd like for you to pause the video for a moment, read through example 2, and look at some of the questions for questions A through F on the other page. And when we come back, we'll discuss them together. So go ahead and make sure you thoroughly read through example 2 first. Okay, so after you've read through that and attempted some of the problems, A says, what does it mean for the experiment to be placebo-controlled? So that means that group received flavored water. The placebo group, that group received flavored water. So they're the baseline because each of the 16 people each of the 16 cyclists here, they did a segment of their, it says for a given trial, 1 beverage treatment was administered throughout a 2-year variable intensity cycling. So they did a segment of their workout when they received the placebo. They did one with the non-caffeinated sports drink, and then they did one while receiving the caffeinated sports drink. So they didn't know which of the segment of their workout they were receiving what. What does it mean for the experiment to be double blind? Why do you think it is necessary for the experiment to be double blind? So double blind means neither the cyclist nor the experimenter know which drink was given during each segment of exercise. Okay. And this might be because they measured their performance. So it says here, for a given trial, 1 beverage. So total work performed during the 15 minutes, the final 15 minutes was used to measure performance. The beverage ordered for the individual subjects was randomly assigned. A period of at least 5 days separated the trials. All trials took place at approximately the same time of day, in the same temperature and humidity. Okay, so it was they measured like their work on the bike. You can measure how many like kilowatts, I think, that of energy you're creating. Okay. So I don't think there is as much of a need to do a double blind in this experiment, but I do know if you were doing an experiment where the experimenter actually had to measure like a visual of the subject. So let's say it was something in psychology, and part of the measurement was that the subject came in and visited with the experimenter, and they had to make visual comments of if they looked fatigued, comments on their conversations. And if an experimenter knew that a certain subject had received or did not receive the actual treatment, they may perceive their discussions, their looks, or their fatigue, or their interactions with the subject a little bit differently based on the fact that they knew they were getting the treatment or did not get the treatment. So that's why a double blind is usually very important. How is randomization used in this experiment? So they randomized, it was double blind, so that was good. And that it was placebo controlled. And they did our repeated measures, which means that they repeated it 3 times. Okay, so they randomly put them in this cycle where they actually perform their cycle with either receiving the placebo, receiving the non-caffeinated drink, or receiving the caffeinated sports drink. So right here, the beverage order for the individual subject was randomly assigned. So not everybody received the placebo first. What is the population for which the study applies? What is the sample? So the population is all athletes or people who are into fitness. So not just professional athletes, all athletes. And our sample is the 16 trained cyclists. And what are the treatments? There was the placebo, which was the flavored water. Then there was the sports drink. And one was non-caffeinated. And the other was the caffeinated. And that one's the main treatment that they're trying to see if it increases their productivity. What is this response variable? And it was the kJs, the kilojoules performed, is what they measured. Performed. So let's look at the steps in conducting an experiment. So there are 6 main steps. One is you need to identify the problem to be solved. What is it you're trying to look at or compare? You need to be very specific. And the statement must also identify the response variable and the population to be studied. Often the statement is referred to as the claim. The second is determine the factors that affect the response variable. The factors are usually identified by an expert in the field of study. In identifying the factors, ask what things affect the value of the response variable. After the factors are identified, determine which factor is to fix at some predetermined level that you're going to be able to manipulate and which to leave uncontrolled. So there's some factors that you know are out there that are going to be more like lurking factors, but you just can't control them. Step 3 is determine the number of experimental units. So as a general rule, choose as many experimental units as time and money allow. But we're going to talk about sample size in chapter 10, or sorry, we've already talked about sample size in chapter 9 and what's appropriate. And then also determine the level of each factor. So there's 2 ways to deal with the factors. You could have a control. So there's 2 ways you can have control. You could have set the level of a factor at one value throughout the experiment if you're not interested in its effect on the response variable. So just you have a control that's the same. Or set the level of a factor at various levels if you are interested in its effect on the response variable. The combinations of the levels of all varied factors constitute the treatments in the experiment. Okay. And the control means they get a little bit of the control as well as the treatment level or variations of the treatment, okay? Kind of like the cyclist. Or you can randomize, which is randomly assigning the experimental units to treatment groups. Because it is difficult, if not possible, to identify all factors in an experiment, randomly assigning experimental units to treatment groups mutes the effect of variation attributable to factors not controlled. So in a randomizing, it might be you're randomized to a group that gets nothing, and then the other, there might be a group that's randomized to actually get the treatment. Step 5 is conduct the experiment. Replication occurs when each treatment is applied to more than one experimental unit. Using more than one experimental unit for each treatment ensures the effect of a treatment is not due to some characteristic of a single experimental unit. It is a good idea to assign an equal number of experimental units to each treatment. Then collect and process the data, measure the value of the response variable for each replication. Then organize the results. The idea is that the value of the response variable for each treatment group is the same before the experiment because of randomization. Then any difference in the value of the response variable among the different treatment groups is a result of differences in the level of the treatment. So you need to know where they stand with that response variable before you even get started. Such as if you were doing something with blood pressure, you need to make sure that if you were doing a treatment for blood pressure, you need to know what their blood pressure was before, right? And what drugs or whatever they were on before you introduce something different. And step 6 says test a claim. This is the subject of inferential statistics. This is what we're going to do in chapters 9 through 11 for our course. Inferential statistics is a process in which generalizations about a population are made on the basis of results obtained from a sample. Provide a statement regarding the level of confidence in the generalization. Methods of inferential statistics are presented in 9 through 15. Like I said, we're only going to be working on 9 through 11. So let's look here on page 51. So explain the completely randomized design. Completely randomized design is an experimental design in which the experimental units are randomly assigned to a treatment. So researchers enrolled 247 women between the ages of 70 and 93 in a study. The women were randomly assigned into 3 groups. The individuals in group 1 attended a computer class 3 times a week. So that's group 1. The individuals in group 2 enrolled in an exercise program 3 times a week for 90 minutes each. So group 2 was the exercise group. And the individuals in group 3 were told to stick with their normal routines. After 6 months, the women were issued a survey that results in an age satisfaction score. The subjects in group 2 had a significantly higher age satisfaction score than the subjects in other groups. And so that was group 2 was the exercise group. Why is this a completely randomized design? And that's because the researcher randomly put them in 2 groups. The women did not get to decide if they were going to be in the computer class or just stay status quo, or if they were going to be in the exercise program. How many levels of treatment are there, and what are the treatments? So we said that there were 3, and it was computer class, exercise program, or status quo, which is stay with normal routine, whatever that was. What is the response variable in the study? And that would be their that age satisfaction score. So age satisfaction score. What variables were controlled in the study? So the only thing that was controlled were really a separate activity each week, right? So basically separate 3 times weekly for 90 minutes. The rest of their day, we don't, as right now, we don't know anything about the rest of their day. So the computer people could have been working out, right? We don't even know. They didn't say if they controlled that. What variable was manipulated in this study? Their time, right? Their activity. Their activity during said time. Explain the role of randomization in the study. So they randomized which group they were going to be in. To what population do the results of this study apply? So we would say all women 70 plus years old. And draw a figure that illustrates the experimental design. So in this, I would say, let's say this rectangle is all of the women in our study, and they were just completely separated into 3 groups. So either computer, exercise, or normal. Okay, those are that's kind of how I would visualize that. So they were randomly, they didn't overlap. So the women were each, so, and it doesn't say how many people were in each. So hopefully it was maybe 247 divided by 3, which would be, it would somehow be odd, right? So it would have been like 82, 82, and 83 women or something like that, right? So something like there was a different number in each one, hopefully about equal. Let's look at a matched pairs experimental design. So matched pairs is an experimental design in which the experimental units are paired up. The pairs are selected so that they are related in some way, i.e. the same person measured twice, twins, married couples, etc. There are only 2 levels of treatment in a matched pairs design. That is a before and after, or the first twin versus the second twin, or the first spouse versus the second spouse. So example 4 here says xylitol has proven effective in preventing dental caries, or cavities, is which we know them, when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. The researchers measured the children's ratings of the 2 types of milk. So it says, what is the response variable in this experiment? And I would say milk taste. Okay, think of some of the factors in the study. Which are controlled, which factors are manipulated? So it would just be the type of milk drank, right? That's the only thing that was controlled here. What are the treatments? How many treatments are there? So there are 2 treatments, right? And they tasted with the xylitol and then without the xylitol. How are factors that are not controlled or manipulated dealt with? They didn't say, right? They didn't share that with us. What type of experimental design is this? It's considered a matched pairs. Identify the subjects. They were all children, right? 75 Peruvian children. and draw a diagram to illustrate this design. So in this, I would say all 75, and then they all got the same thing, but it would be compared with a width. So it would be 1, 2, all the way down to all 75 children, right? And they're going to compare with xylitol and without xylitol. So they're going to do some kind of a flavoring before and after. Whereas before, in our previous one, it was going to be a separate group of women in each. There was no overlap, so no overlap here. In the first one, on the completely randomized. So the last type of design that we're going to look at for experimental design is called explain the randomized. We're going to talk about a block design. So block design is grouping together similar or homogeneous experimental units and then randomly assigning the experimental units within each group to a treatment. Okay, which is called blocking. Each group of homogeneous individuals is called a block. So an experimental design, randomized block design, is an experimental design in which the experimental units are divided into homogeneous groups called blocks. Within each block, the experimental units are randomly assigned to treatments. So, for instance, suppose we conduct a study designed to measure reaction time to a stimulus in sleep-deprived individuals. To do the study, we identified 100 individuals between the ages of 20 and 29. 50 of the individuals are assigned to a control group and 50 are assigned to an experimental group. The individuals in the control group are allowed to sleep 8 hours before the study, while the individuals in the experimental group are kept up all night. Other variables that are thought to affect reaction time are controlled and fixed at a single level, such as food intake and the morning of the test or age of the individuals. Variables that are not controlled are dealt with through randomization. The following morning, all 100 individuals are given a test where they push a button upon seeing a red light on the screen. Time needed to push the button was recorded. Because it is possible that reaction time differs by gender, it would make sense to block by gender. Let's say we have 60 females and 40 males in our study. We should randomly assign 30 of the females to the control and 30 females to the experimental. Also randomly assign 20 males to the control and 20 males to the experimental. So for this study, right, we have 200 individuals. We have 100 individuals. So, and it said we had 60 of them were female. So 60 were female. And 40 were male, right? So 60 and 40. And so what we would do is we would say, okay, we're going to break it up here. We're going to say 30 of the females would be in the control group. So 8 hours sleep. And 20 of the males would also be in the control. Right. And then we would have 30 of the females, the other 30 of them in the no sleep. So no sleep. And then the other 20 of the males in the no sleep. So we're controlling for gender, and then we're also controlling for the sleep versus no sleep. So that is the end to lesson 1.6. And now that you've got some knowledge about experimental design, you can go ahead and move on into chapters 10 and 11. See you then.